I'm going to ask a question before I proceed. Today is September 22, 2021. Do you have any specific questions or any specific problems that you want to address?
None currently to me. This is Charlene Jackman.
Okay, Charlene Jackman, go ahead.
I don't have any questions currently.
Okay, all right. So I take it that nobody has any questions. So what I'm going to do is I'm going to basically introduce a concept that I believe all of you understand already. And we're going to try to solve some problems from the homework assignment. And so as to illustrate to everybody how those problems should be solved and presented. All right. So I'm going to, first of all, I'm going to share screen. I'm going to share screen so that you see the problems, and then we will proceed to try to address them. So give me 1 minute. Okay. So the first screen share that I'm going to do will be to look at the time value of money. Okay, so this is the basic time value of money. And I believe that you are all familiar with this from your first finance class. And so essentially, the objective here is to understand that money in the hand is is more valuable than money to be received in the future. And so we go through a compounding process to evaluate money. Okay, so let us look at, say, present value. Okay, let's look at present value. I'm going to take a simple problem. And I try to solve through it. And I believe you all understand the basic concept of present value. So I'm going to stop share this. I'm going to pull up a problem, and we're going to go through it. Now, if you want something different, please feel free to stop me. Okay, so you see the problem that I have here. Okay, so you would like to have $50,000 in 15 years. And to accumulate this amount, you plan to deposit an equal sum in the bank each year that will earn 7% interest compounded annually. Your first payment will be made at the end of the year. Okay. So what you're asking yourself is, how much money are you going to invest today to earn $15,000 in 15 years, or $50,000 in 15 years? And you know, at least you have information that the money will earn 7% a year for the 15 years. Okay. So the question here is, you're asking yourself, what is the future value of an accumulation, that is, periodic payments? Okay. So this is the future value of an annuity. So this problem we're going to solve as future value of an annuity, because you're going to make periodic payments. So this is an annuity. I'm going to, are you seeing my screen?
Yes, I could see, Professor.
Yes, Professor.
Okay. So this is an annuity problem, okay? Because you're going to make periodic payments. You're going to make periodic payments in equal installments. You have an annuity, okay? And then in this particular case, you are looking at the future value of annuity, all right? And the way to solve for future value of an annuity is LVFA will be equal to the annual amount, okay? Let AM to represent annual amount times FV FA, the future value of an annuity, the future value interest factor for an annuity at 7% for 15 years. Okay. All right. So then how do you calculate the future value interest factor for an annuity? This is a formula that you can do on your Excel spreadsheet, or you can use the formula. The formula is very simple. Okay. Formula is very simple, and so you can also look up the future value interest factor for an annuity from a table, which I really prefer that you learn how to calculate. Okay, so let's just be patient and walk through this formula. Okay, so just give me a second, and we're going to walk through a formula. And there are two parts of this question, and I'm not going to solve all your homework problems. I'm just going to solve this one. The other part of the question says, if you decide to make a large lump sum payment today instead of annual deposits, how large should this lump sum deposit be? Okay. Okay, so we're going to do that one. And the other problems here are quite similar. Okay. Okay, so here we're going to specify the interest, okay, the interest rate, okay, the interest rate, and I'm going to interest rate is equal to we're going to symbolize it as K, and the number of periods is equal to N. Okay. And so the future value interest factor could be calculated as simply as going to use an equation, going to I hope let's see if I can draw it. Okay, will be okay. So this is the future value interest factor for an annuity. And of course, you multiply that by the annual amount, and I'm going to call it A. And so here, K is 7%, which is 0.07. Okay. So in this particular problem, K is equal to 7% or 0.07. And N, the number of periods, is 15. So we can easily take this. Now, the FVA we are looking for, FVA, the future value that we're looking for, is how much? Is $50,000. That is how much we're looking for. Okay, and so we can take this, put it there. So $50,000 we know. What we don't know is A. So this will be 0.07. And we know the number of periods. Actually, this is wrong here. It should be divided by K. Should be 0.07. And so now you can solve for A. Okay. So here we solve for A. So first of all, we have to find out what is the interest, the future value interest factor. And so we find 1.07 to the power 15. In that case, 50,000 will be equal to A times 1.07 to the power 15 minus 1, which is equal to So this here, can somebody solve that 1.07 to the power 15 so that we're sure that you are following what I'm doing? When I have the answer, somebody help us? Hello?
For the top part, I got 1.759.
Okay, so that is
Over
2.759 minus 1 over 1.07. So
I
you're
did the
correct.
-1 already.
I understand. I say you're correct. So I said you're correct. So that will be 1.759. And so we have, this is 1.759 over 0.07, which is, what is 1.759 over 0.07?
I got 25.129.
Over 0.07. Thank you very much for helping. 25.129, which is, so we are now saying that 50,000 is equal to 25.129 A times 25.129. So what do we have? What is A? What is A? Can somebody tell us what A is? If 50,000 is A times 25.129, let me not confuse everybody here. All right. So what is the periodic amount? Hello?
I got 1256450.
I don't think so.
No. I'm multiplying 50,000 by
50,000,
25.
let me be sure. 25.129.
I'm dividing it.
No, you're not correct. Could you please do your division again?
Sorry, Professor?
Can you do your division again to find out what A is, the periodic amount?
Yeah, I didn't divide it. Hold on. Yeah, 1989.73.
Correct. So A is equal to 50,000 over 25.129, which gives us 1989.73.
0.73.
Okay, so that is our amount. So this problem requires that you do the future value of an annuity. Future value of an annuity, and the annuity is 1,989 a year. If you invest this periodically over a period of 15 years, at the end of 15 years, you will accumulate $50,000. All right, that's what's going to happen. You will accumulate $50,000. All right, now the other question, the question that follows says, if you decide to make a large lump sum deposit instead of annual deposits, how large should this lump sum be? All right. So in that case, what you're doing is a one-time investment. you are no longer looking at an annuity. You're just going to look at a one-time, an investment for one period of time. And so it will just be a future value. Okay. So I'm going to take this and modify it. Okay. To just be a future value. And so it will be a plain future value. What is the future value amount? And so the rest of the formula is going to be modified. And so this is going to be divided by 1. Okay. Or quite simply, the future value that you will accumulate future value will be equal to a lump sum amount times one plus k to the power n. Okay, so again, if you take this, the future value would be 1 plus 0.07 to the power 15, and that should give us what? Okay, so what is 1.07 to the power 15? This implies that 50, let's make it simple. So 50,000 will be equal to an amount times, what's 1.07 to the power 15? Can somebody help me out? Yes. Anybody home? Hello? Should be
That's 2.759.
2.759. Okay, that is not hard to get. And so what is A? So now you solve for A, which means then that we have 50,000 A equals to 50,000 over 2.759. And what does that give us?
18122.50.
Okay.
You heard me?
Yes, 18,122.
Yes.
Okay, which is 18,122 point, I get 0.30, but that's not, that's just a calculator rounding outcome, not an error, just a calculator rounding outcome. So if you wanted to make a one-time lump sum payment today and simply forget it, and you look forward to your 7% compounded annually over 15 years, you would make a deposit, a lump sum deposit of 18,122 today. In 15 years, you will have $50,000. That's it. Okay. Now, that is the way I want you to present this problem. If you have solved it and submitted it, you can request that I clear your solution, and please follow the same procedure in detailed form to present your answers for the other questions. Okay, so that is like the assignment for week 3. You do the same, go through the same procedure, and solve the other problems. Okay. If I ask for a spreadsheet, please give me a spreadsheet. If I ask for a table, give me a table. Now, we have the problems for week 4, which I'm going to go into because now you have applications. Okay. All right, so that does it for that. So let's look at the problem in week 4. I'm going to again solve the very first one. Okay, I'm going to solve the very first one. Are we following?
Yes, Professor.
Yes, Professor.
All right.
Yeah.
All right. So now, this is week 4 problem. Now we are dealing with some applications, okay? And so your company has an outstanding mortgage on a building on which it originally borrowed $140,000 for an 8-year mortgage at 10.75% annual rate of interest. The mortgage is paid quarterly. What is the quarterly mortgage payment on the property? Prepare an amortization table for the mortgage. Okay, so here, this is an application of future value. An application of time value of money. So now, but this problem is a present value problem. Okay, this new problem is a present value problem. So you are now going to calculate the present value of an amount, in the sense that you are now going to, you have now received a money. You have now received a sum of money today. And so the question is, what amount of money are you going to be depositing to be able to get an equivalent of the money that you received today? So you're going to be solving for the present value of an annuity. Okay. So in this case, we're going to define the periods. Okay. So quarterly, now that means we have 8-year mortgage to be paid quarterly. So we have 4 times 8, which equal to 32 periods. So in that case, 10 is equal to 32. We'll define the number of periods. I'm going to make this bold until we are done. Okay. All right. So we have 32 periods. So the rate of interest okay, is equal to 0.1075 divided by 4, which is, because now you're going to divide the interest by the 4 periods, which is 0.026875, 0.026875. Now this is going to be your the present value is equal to 140,000. The present value is 140,000, and so you're going to use the present value interest factor for an annuity, and so 140,000 will be equal to a periodic amount times PVIFA of 0.026875 for 32 periods. Okay. Generally, this should be made like a subscript to make clear what we're doing. Okay. So this is what we have. So the question is, how then do you calculate the present value interest factor? I'm going to borrow from what we have already, since this is a problematic thing to do. I'm going to borrow from this and simply switch things around properly. So 140,000 is going to be equal to A times it's going to come out. I will have 1 minus minus n. Okay, so you can see we have a different formula here. So this implies that $140,000 equal to 7 to the power minus 15 divided by 0.07. So can somebody give me the calculation of 1.07 to the power minus 32? Sorry. Why are you guys keeping silent?
Professor, why you have 7 there when it's 8 years and 10.7%?
And this is why I was asking why you guys keeping silent.
Okay.
0.26875, and this is 0.26875. All right. This is why I'm protesting. What are you guys doing? I thought I had friends in high places. Okay, to the power minus 32. All right. So equal to This is 0.427993. 0.1 minus 0.427993. 738. All right. So now this is what you have. So 140,000 will be equal to A times 1 minus 0.427. And so the answer would be, can somebody give me an answer? 40,000 will be equal to 1 minus that will be okay, 0.572006, 0.57200626. Okay, divided by 0.57200626 over that will be equal to, so now we have that 140,000 equal to A times over 1026875 21.28395 21.28395 28395. Which you mean then that A is equal to what? Can somebody find A for me?
6,577.72.
Okay, 6,577.73. Okay,
Okay.
should be 6,577.73. So that is the solution to the first part. What is the quarterly mortgage payment on the property? Okay, so now what I'm going to do is now prepare an amortization table for the mortgage. This is where now we're going to have to switch. All right, so I'm going to save this file and then switch to Excel, and I'm going to write down the periodic payment 6,577.73 and N is 32 and the amount is 140,000 and the rate of interest is 0.026875. You write all these things down and I'm going to switch so that but I save this. Okay. And this is 4. I'm just going to call it because I'm going to bring it back. Okay, I'm going to stop sharing it. So what I'm going to share now is a spreadsheet. Okay, I'm going to share a spreadsheet. a blank spreadsheet. So let us share. Are you seeing my spreadsheet? Hello, friends.
Yes,
Yeah.
Professor.
Yes.
Very good. Okay. So we have period. Okay. Period 0, period 1. And so we have here 32 periods. Okay. And so we have payment amount, payment. Payment begins from period 1, which is 6577.73, 6577.73. Okay. And that is constant. 32 periods. Okay. Okay. And so you pay interest. Okay. And how much of your payment is principal? Okay. And then you have a balance. So you start from a full balance, down from a full balance. Okay. And so your balance at the beginning is 140,000. Okay, that is your beginning balance. I like to be a little fanciful sometimes. All right, so I have a bold. And so how much interest do you pay? The interest you pay will be 0.026875 times L7, which is the original, the amount of the balance. Your principal is equal to the payment, which is I8, minus J8, which is the amount that is deducted for interest. And so your principal that you paid, that means you paid 6,577, 3,762 is taken for interest, and you receive credit for 2,815 for payment towards the loan. So your balance becomes equal to L7 minus K8. That is your balance. Now you can take this whole thing and drag it down. And so at the end of 32 periods, you can see now you have a negative balance. So actually at the end of 32 period, the 32nd period, you're going to receive a refund of 659, but what you're seeing is that you paid off your loan. Okay, but you can see how easy and straightforward it is, except for the time that you take to solve for the periodic payments. So, and then you can take this, and stop share. We can now take this and then and paste it. And I want to see that table. This is not hard to do. All right. So you can see that. See if I can reduce it a little bit. Right. So you have a solution. I'm going to mark that solution in red. So this is your solution for that problem. So I want to see that solution up there on how you were able to obtain the periodic amount. But you can also use the Excel formula. It's in your, you have an Excel. You can use the routine in Excel to get the amount, as long as I see what you're doing. Okay, and then you plug in the amount into here. You don't have to go through this process of solving an equation. If you don't want to do that, you can just use the Excel facility to solve for the periodic amount. And once you get the periodic amount, then you can now make a table. Now, doing the table is where you're gonna really put in some energy. Okay. All right, so does anybody have any questions? I did those two examples to show you what I expect from you. And once you do that, you have no issues. If you have submitted the problem and you think you want to do it over, please let me know and I will clear what you submitted and you can resubmit. Any more questions? Okay, hearing none, I take it that we have nothing more to say. I'm just going to take off some of this so that everything is on one page there, but doesn't mean anything. All right. I mean, you have only 26 periods, so maybe we can have it also at least you can see what happened at the end, that you paid off your loan and you had some change. All right, that's it for now. And so I'm going to stop share.
Professor, this is Charlene Jackman. Could you send back my assignment or whatever magic you do?
Can I do what?
Send back my assignment. I think I submitted it today.
Okay, so all you have to do is send me an email.
I'll send you an email. Okay, no
Yeah, send me
problem.
an email and I'll just clear the assignment for you, so you can redo what you want to do.
Redo it and send it back. Okay, for both.
Yeah, just
week
send me an
2 and
email.
week 3 and week 4, Professor.
I will extend the due date for week 3.
Okay. All
Okay.
right, no problem. Thank you. So I'll
All
send you the email when I'm done.
Professor,
Okay.
I wasn't. This is Angel. Professor, I wasn't able to submit the last homework because I hardly understood it. So can I reach? Can I? Are you?
Yes,
gonna send that homework?
I will reopen the assignment and extend the deadline.
Okay. I
Okay.
appreciate that. Thank
Okay.
you.
I will reopen the assignments and extend the deadline.
Okay.
So that's for all the assignment professors.
For assignment number week 3 and assignment week 4.
Okay, thank you. I appreciate it.
Okay. Okay, I can see somebody likes
So this
donuts.
is the end of the class, Professor.
What did you say?
This is the end of the class.
This is the end of the class. As I said, does anybody have any other questions? I'm hearing none. I'm ending the class.
No, I don't have any more questions.
All right.
No, I don't have any more questions. I'm just happy that you extended so I could go ahead and do it the right way.
Yes,
Yep.
please. All right. Good night, everybody.
Hi, Professor.
All right, good night.